Next, we'll talk about efficient data warehouse schema design. Take a look at the original data table here and the normalized data tables which contain the same data. The data in the original table is organized visually, as you might have used merged cells or columns in a spreadsheet. But if you had to write an algorithm to process the data, how might you approach it? Could be by rows, by columns, by rows then fields, and the different approaches would perform differently based on the query. Also, your method might not be parallelizable. The original data can be interpreted and stored in many ways in a database. Normalizing the data means turning it into a relational system. This stores the data efficiently and makes query processing a clear and direct task. Normalizing increases the orderliness of the data. It's useful for saving space. Many people with database experience will recognize this procedure. Normalizing data usually happens when a schema is designed for a database. Denormalizing is a strategy of allowing duplicate field values for a column in a table in the data to gain processing performance. Data must first be normalized before it can be denormalized. Denormalization is another increase in the orderliness of data. Data is repeated rather than being relational. Flattened data takes more storage, but the flattened non-relational organization makes queries more efficient because they can be processed in parallel using columnar processing. Specifically, denormalizing data enables BigQuery to more efficiently distribute processing among slots, resulting in more parallel processing and better query performance. You would usually denormalize data before loading it into BigQuery. However, there are cases where denormalizing data is bad for performance. Specifically, if you have to group by a column with a one-to-many relationship. In this example shown, order ID is such a column. In this example, to group the data, it must be shuffled. That often happens by transferring the data over a network between servers or systems. Shuffling is slow. Fortunately, BigQuery supports a method to improve this situation. BigQuery supports columns with nested and repeated data. In this example, a denormalized flattened table is compared with one that has been denormalized, but the schema takes advantage of nested and repeated fields. Order ID is a repeated field. Because this is declared in advance, BigQuery can store and process the data respecting some of the original organization of the data. For this reason, nested and repeated fields is useful for working with data that originates in relational databases. Nested columns can be understood as a form of repeated field. It preserves the relationalism of the original data and the schema while enabling columnar and parallel processing of the repeated nested fields. It's the best alternative for data that already has a relational pattern to it. Turning the relation into a nested or repeated field improves BigQuery performance. Nested and repeated fields help BigQuery work with data sourced in relational databases. Look for nested and repeated fields wherever BigQuery is used in a hybrid solution in conjunction with traditional databases.